Hello everybody, welcome. So we are studying the fourth module of our engineering mechanics, that is dynamics of rectilinear and curvilinear motions. Dynamics of particles or bodies with rectilinear and curvilinear motions. So we are studying kinematics and kinetics of rectilinear motion and curvilinear motion. So we have divided this module into four parts: kinematics of particles having rectilinear motion, kinetics of particles having rectilinear motion, kinematics of particles having curvilinear motion, and kinetics of particles having curvilinear motion. And we are studying our first part. First part is kinematics of particles or kinematics of bodies subjected to rectilinear motion. So yesterday we saw about the basics and we saw 4 problems. So today we will see some 6 more problems. With that we will complete this section, and from tomorrow we will go for the next part, second part. So in this first part, yesterday we did 4 problems, and some of you have raised doubt on the third problem, that is this problem. The position of the particle which moves along a straight line is defined as S is equal to t cube minus 6t square minus 15t plus 4, where S is expressed in meter and time in seconds. Determine the time at which the velocity will be 0, the position and distance travelled by the particle at that time, the acceleration of the particle at that time, and the distance travelled by the particle when t is equal to 4 to 6 seconds. Listen, the doubts raised were on the fourth part, D part, that is the distance travelled by the particle when t is equal to 4 to t is equal to 6 seconds, from 4th second to 6th second. The doubt was, why don't we take S t is equal to 6 minus S t is equal to 4. You can take, of course you can take it like that, but for this particular problem you cannot. The reason is, see, you would have calculated, if you calculate for this problem, if you calculate S t is equal to 6 minus S t is equal to 4, that is distance at the 6th second minus distance travelled by the particle in the 4th second will be equal to, you will get minus 8 plus 10, that is equal to 2 meters. But our actual answer is not 2, it is 18 meters. That is, from 4th second to 5th second, it has travelled minus 8 meters, and from 5th second to 6th second, it has travelled 10 meters. So totally it is 18 meters. Distance cannot be minus negative value. So totally it is 18 meters. But what has happened here is, see, at t is equal to 5 seconds, you can see this D part. Now you would have calculated yesterday at t is equal to 5 seconds. That is, in the A part, it is said that V is equal to 0, that is velocity is equal to 0, and we found that velocity is equal to 0 at a time is equal to 5 seconds. See, this 5 seconds lies between 4 and 6, 4th second and 6th second. That means between this 4th second and 6th second, the velocity becomes 0 at the 5th second. That is, between this 4th second and the 6th second, the velocity has reached its maximum distance and it has returned back. That is the meaning of that. The particle is moving in one direction, it has reached the maximum limit, that is at a t is equal to 0, the velocity is equal to 0. Then it is returning back. So the values from 4th second to 5th second, the value for S is minus 8. It is travelling in one direction. and from 5 to 6 seconds it is traveling in the opposite direction, so it is 10. That is why the distance here it is calculated as s at t is equal to 5th second minus s at t is equal to 4th second plus the distance travelled between the 5th and 6th second. If v is not equal to 0 at 5th second, and if it is continuously increasing, you can definitely find it by s is equal to 6 seconds minus s at t is equal to 4 seconds. You will get the answer. Otherwise, the problem is you will get one distance in negative value and another distance in positive value. So, by adding you get the difference, not the summation. But for calculating the distance, we need how much is the distance, how much is the total distance travelled. So, it is the summation of both the distance travelled in both the direction. That is why it is, for this particular problem, it is calculated as the distance when the distance is travelling from 4 to 5 seconds and then from 5th to 6th second. Hope you are clear now. Now we will go on to problem 5. This is yesterday's problem. So we are moving on to problem 5. So today we will have 6 problems, 5, 6, 7, 8, 9 and 10. So, okay, we will go to the problem. Okay, we are going to problem 5. A ball is tossed with a velocity of 10 meter per second directed vertically upwards from a window located 20 meter above the ground. So the ball is located at this point. The ball is present at the window and the window is 20 meter above the ground level. This is the ground level. This is the ground level. Now, the acceleration of the particle is constant and it is equal to 9.81 meter per second square. So, acceleration, downward acceleration is 9.81 meter per second square. So, we will take the upward acceleration as minus 9.81 meter per second square. We are asked to determine the velocity. Now, the ball from the window, the ball is thrown with a velocity of 10 meter per second. So, we take v is equal to 10 meter per second when t is equal to 0. And yes, that is the starting distance is 20 meter from the ground level. Acceleration is minus 9.81 meter per second square. So, we integrate the acceleration. We get v is equal to minus 9.81 t plus c1. c1 is constant of integration. So, by substituting v is equal to 10 and t is equal to 0, we get c1 is equal to 10. By substituting c1 is equal to 10, we get the equation of velocity as v equal to minus 9.81 t plus 10. Now we will find the equation of the displacement by integrating the velocity. We know v is equal to ds by dt. So, v is equal to minus 9.81 t plus 10. So, from this we get ds is equal to minus 9.81 t plus 10 into dt. So, we integrate the velocity, we get distance is equal to minus 9.81 t square by 2 plus 10 t plus c2. By substituting s is equal to 20 and t is equal to 0, we get c2 is equal to 20. Therefore, the equation of the displacement when the ball is thrown with a velocity of 20 meter per second is minus 9.81 t square by 2 plus 10 t plus 20. Now, stage 2, the ball is reaching its highest elevation. When the ball reaches its highest elevation, we know the velocity will be equal to 0. At the highest point, the velocity will be equal to 0 because at 1 second, for a particular moment, the ball stops and then comes down. So, velocity at that point is equal to 0. So, We know this is the equation for velocity. So substituting velocity is equal to 0 in the equation of velocity, we get time is equal to 10 by 9.81 second. That is, at t is equal to 10 by 9.81 second, we get the maximum height, and that is equal to 25.0968 meter. 25.0968 meter from the ground level and 5.0968 meter from the window. We'll move on to the next problem. The speed of the particle is given by v is equal to 2t cube plus 5t square. What distance does it travel while its speed increases from 7 meter per second to 99 meter per second? So how will you do this problem? Velocity is given. Equation for velocity is given. Integrate the equation of velocity. We will get equation of the displacement. Now, our velocity is increasing from 7 meter per second to 99 meter per second. So, we will find the time when the velocity is at 7 meter per second, our time is 1 second. So, substitute v is equal to 7 in the equation of velocity. And velocity is increased to 99 meter per second when time is equal to 3 seconds. Now, the total distance will be equal to, total distance travelled from 1 second to 3 seconds will be equal to the distance travelled in the 3 seconds minus distance travelled in 1 second. So, we get 83.333 meter. Seventh problem. A particle starting from rest moves in a straight line and its acceleration is given by a equal to 50 minus 36t square, where t is in seconds. Determine the velocity of the particle when it has travelled 52 meter. So here acceleration, equation for acceleration is given. So our equation of velocity is obtained by integrating the acceleration. By integrating the acceleration, we get v equal to 50t minus 12t cube. By integrating the velocity, we will get s is equal to 25t square minus 3t raised to 4. So, we have to find the velocity at s is equal to 52 meter. So, substitute s is equal to 52 meter and find what is the time. We will get two values for time, that is 2.0816 second and 2 seconds. Now, for these two time interval, we will find what is our velocity. That is, see, we have two times. One is 2 and another one is 2.0816. So, 2 is the lowest time period. The largest time period is 2.0816 second. At t is equal to 2 seconds, in order to reach 52 meter, we have to travel with a velocity of 4 meter per second. And at t is equal to 2.0816 second, for reaching the distance of 52 meter, you have to travel back with a velocity of minus 4.163 meter per second. Now, problem number 8. A driver of a car is traveling at 72 kilometers per hour. So, this is 72 kilometers per hour. So, we converting 72 kilometers per hour, we will get 20 meter per second. So, the velocity of this car is 20 meter per second. Observes the traffic light 300 meter ahead. So, the distance between the car and the traffic light is 300 meter. The ahead of him turning red. So, this is red now. The traffic color is red now. The traffic light is timed to remain rest for 20 seconds. So, from here to till the color changes from red, the time available is 20 seconds. Now, if the motorist wishes to pass the light without stopping to wait for it to turn green, determine the required uniform acceleration of the car. So, substituting, we know s is equal to ut plus half at square. Substituting s is equal to 300 and u is equal to 20 meter per second. And time is equal to 20 seconds. We get acceleration as minus 0.5 meter per second square, that is deceleration. So, because he is moving with one velocity, 20 meter per second. So he has to reduce his velocity. He has to reduce his acceleration to minus 0.5 meter per second square. Now, second part, the speed with which the motorist crosses the traffic light. So, with what speed, that is final speed, is equal to this initial speed, that is 20 meter per second, plus the acceleration minus 0.5 into t. We get the answer. Now, ninth problem, a stone is dropped into a well. So, this is the stone. So, this stone is dropped into the well. The sound of the splash is heard 3.6 seconds later. That is, this T1 plus T2. T1 plus T2, we get 3.63 seconds. How far below the ground is the surface of water? We need to find h. This is height. We need to find h. Assume the velocity of sound as 331 meter per second. Now, see, T1 is the time taken for the stone to reach the surface of water. T2 is the time taken by the sound to travel from the water surface to the ground surface. So, first of all, while considering the stone, when the stone is dropped, u is equal to 0, initial velocity is equal to 0 at a time t is equal to 0. So, we get the height is equal to ut plus half at square. Ut plus half at square. It is dropped downwards. So, u is taken as 0. So, for reaching it will have time t1. Half g is taken as 9.81 t1 square. So, this is equation number 1. Now, when we are considering the sound, for the sound to travel from the surface of water to the ground level is T2. It is given it is traveling with a velocity of 331 meter per second. So, sound travels with a velocity of 331 meter per second with an uniform velocity. We assume the velocity to be uniform, therefore, the acceleration is taken as 0. Therefore, height is equal to ut plus half at square, acceleration is 0. So, we get ut. Here t is T2, u is 331. Now, we have two equations for height, equating 1 and 2. So, 1 is equal to 2, we get time t1 is equal to 3.4533 seconds. T1, we will substitute T2 is equal to 3.63 minus T1. So, we get T1 is equal to 3.4533 seconds. Now, substitute in any of the equation, we get h is equal to equation 1 or 2. We get h is equal to 58.4935 below the ground level. Now, so the last problem is a ball is thrown vertically up with a velocity of 30 meter per second. Determine the time when the ball is 20 meter above the point of projection. So, it is thrown vertically upwards, a equal to minus g, s is 20 meter, u, it is thrown with a velocity of 30 meter per second. So, we will apply h is equal to ut plus half at square, substitute h is equal to 20 meter, u equal to 30 meter per second, a equal to minus g, that is 9.81 minus 9.81, we get time t is equal to 0.7614 for going upwards, and by substituting g is equal to 9.81, we get t equal to 5.345 seconds while coming downwards. So, when the velocity will be, first when the ball is 20 meter above the point of projection, the time is 0.7614 seconds. Now, second case, when the velocity will be 5 meter per second. So, initial velocity is 30 meter per second, final velocity is 5 meter per second. Substitute v is equal to u plus at, we get t is equal to 2.545 seconds. Third, when it returns back to original position. So, how much time it requires for returning back to its original position. Listen, for the first case, while the ball is moving upwards, going up, it takes 0.7614 seconds to reach 20 meter. It goes up, then it comes down. At a point, it reaches its velocity to 0, then it comes down. And when coming down from the maximum position to 20 meter height, the time taken is 5.354 seconds. Now, I hope you understood. See, the ball is thrown upwards at 0.7614 seconds. It reaches 20 meter, goes up and comes down at 5.354 seconds. It reaches and t is equal to 2.354 seconds while coming down. Now, the third part, let t is the time required to reach the maximum height. Therefore, the total time required to reach the original position will be equal to 2t. So, by substituting u is equal to 30 meter per second, v is equal to 0, that is at maximum height v equal to 0. Since it is going up, a is equal to minus g. By substituting this, we get the time required to reach the maximum height as 3.0581 seconds. So, the total time required to reach the maximum height and then to reach the ground is 3.0581 multiplied by 2. We will get the total required time. Thank you. Hope you all understood. Once again, thank you.